Hi, hope you all are good. And today's topic is deduction of elements in organic compounds. We all know that organic compound, hydrocarbon instance, which has carbon and hydrogen in it, right? And other than that, we have many other elements also possible to be in, like oxygen, sulfur, phosphorus, halogen, nitrogen, right? So there is different tests for to find out these elements whether it is there in the organic compound or not, right? So we are going to see about those qualitative analysis, which means we can't say how much gram of that element present in organic compound by doing these methods. Okay, we can find only whether that element is present or not. Okay, fine. So first, deduction of carbon and hydrogen. Actually, this is easy as well because we know carbon and hydrogen is there in the organic compound, right? But still, we have used this method to confirm that. So unknown compound 1 mole we have to take, or 1 ratio, and the 3 ratio of pure dry cupric oxide. So cupric oxide, okay, pure cupric oxide. So pure and dry. Why dry cupric oxide in the sense? Cupric oxide is hygroscopic. Hygroscopic in the sense like kind of deliquescent. How the rock salt is deliquescent. If you keep it in the atmospheric air for some time, it absorbs the moisture from the atmospheric air and it becomes liquid. But over here, hygroscopic, it will absorb moisture, but not, it will not become liquid, right? Okay. So we need dry cupric oxide. So we have to heat it to remove all the water from it, and the anhydrous cupric oxide we use here. Okay. So 1:3 ratio we have to take. Now, the apparatus setup, I'll explain you. In a hard test tube, we have to take this mixture. So what is it? Unknown compound, and cupric oxide. Okay, cupric oxide, CuO, unknown organic compound. Okay, yeah. So in this bulb, connected with a delivery tube which has a bulb in it. The hard test tube connected with a delivery tube which has a bulb in it. Okay, and the delivery tube connected to the other beaker or another test tube, okay, which has lime water, okay, which has lime water, which is calcium hydroxide. Got it? Okay. So now listen carefully. By heating this hard test tube, the hard test tube has unknown organic compound and copper oxide, cupric oxide. So this bulb, this bulb contains copper sulfate in it. Okay, copper sulfate. Copper sulfate, which is white in color. That means anhydrous copper sulfate. Got it? Anhydrous copper sulfate. That means it is white in color. Okay. So when you heat this mixture, if hydrogen is present in it, that goes as water vapor. When the water vapor reacts with copper sulfate, when water vapor reacts with copper sulfate, that becomes CuSO4 dot 5H2O. So that means what? It becomes hydrated copper sulfate. So blue color solution, you'll get it, right? Blue color solution over here, copper sulfate, 5 moles of water leads to blue color copper sulfate. That means hydrated copper sulfate. Okay. If carbon present in it, okay, that carbon goes as a carbon dioxide, and that reaches the container which has calcium hydroxide. So calcium lime water is a test to find carbon dioxide, right? Test for CO2. When lime water turns milky white, that means it becomes calcium carbonate when the carbon dioxide reacts with it, right? So over here, same thing. Okay, how it gets carbon dioxide? When carbon with when carbon, in the sense the carbon present in the organic compound reacts with cupric oxide, so it goes as carbon dioxide when you heat it. And the copper will be there in the hot test tube, and the carbon dioxide escapes here, liberated by this. So it reacts with CaOH twice, I mean calcium hydroxide. Am I right? So over here, calcium carbonate, you'll get it, which is white precipitate. So arrow downwards, right? So if hydrogen is present in it, hydrogen reacts with copper oxide, cupric oxide, and it goes as water molecule, and copper stays in the hot test tube, right? So this is how we detect carbon and hydrogen, which is there in the organic compound. Okay, next up. Detection of oxygen. Actually, there is no much process to detect the oxygen, but we can try this, like atmosphere, in the atmosphere of nitrogen. That means you create inert atmosphere. In the inert atmosphere, the unknown compound will, if the unknown compound has oxygen, by heating that unknown compound, you will get a water droplets. What they're talking about, in test tube, if you take the organic compound, when you heat the organic compound, if oxygen is there, if it is hydrated, or if hydrogen and oxygen is there, you will get a water droplets. That means what? The water vapor which escapes condenses and becomes water droplets. So if you can see the water droplet in the sides of the test tube, that means it has oxygen in it. Okay, because water has oxygen in it, so that means oxygen. So this is how you can. But other than that, there is no like exact method to find oxygen. Okay, yes. Then detection of nitrogen. Detection of nitrogen over here, soda lime test, first test. And over here, the unknown compound 1 ratio and 2 ratios of soda's lime. Okay, soda lime, which is the caustic soda, sodium hydroxide, and lime, CaO, calcium oxide. So soda lime. So 2 ratio of soda lime with 1 ratio of unknown compound. And if you heat this mixture, it evolves ammonia. That means you'll get pungent smell. That pungent smell confirms it has nitrogen. Okay, so ammonia has nitrogen, so it has nitrogen. It confirms that it has nitrogen. But the nitro and diazo. Nitro means what? Nitro, NO2. Diazo, N triple bond N, right? So nitro and diazo compounds does not respond to soda lime. So it is not the conclusive test. It is not the confirmatory test, because since there is no pungent smell, we can't say no nitrogen in it, because the nitro compounds and the diazo compounds does not respond to it. Okay, so what we have to do? Then we have to go to confirmatory test. So the confirmatory test is Lazane's test. Okay, Lazane's test, which means sodium fusion test or sodium extract test. Okay, what is it? Listen carefully. Ignition tube, which means a very small tube. Okay, in the injection syringe cap and all will be then like that, very small tube. Okay, so even more small it is. Ignition tube, this much size only, and very thin. Okay, so ignition tube. That in the ignition tube, we have to take a small piece of Na, sodium. Okay, a very small piece. Okay, piece of sodium metal into it, and we have to heat this ignition tube. So heat till sodium melts. Okay, then add 50 to 60 milligram mg, 50 to 60 mg of organic compound to it, and heat it. So by heating it, heat it till it becomes red hot. Okay, till the tube turns into red color. Okay, red color. heat it so that the sodium and the organic compound will react. Okay, so heat till it becomes red hot. Once it becomes red hot, put it in a china dish. Okay, so what happens here? It breaks. So because it is red hot, and if you put in 5 to 10 ml of distilled water immediately, it breaks, right? So, or we can grind it with mortar and pestle and then filter it. Then you can take the extract in the china dish. Okay, that also we can do. Okay, then so after that, I mean, where once you take the red hot ignition tube in china dish, you have to boil the mixture. So by boiling the mixture, I mean boil the broken ignition tube, or you can filter it, then you can boil it, or boil it, then you can filter it, anything. Yeah. So that you get sodium cyanide here. The filtrate has the final solution as sodium cyanide. So sodium reacts with a carbon atom which is there in organic compound, and nitrogen which is there in, because this is for nitrogen, test for nitrogen. So when nitrogen is there, it leads to NaCN. Okay, so sodium cyanide. So once you get sodium cyanide, if excess of water reacts with sodium, okay, I mean the remaining sodium, the metal which we have taken, and we have 5 to 10 ml of water. The excess of sodium is there, water is there. The water reacts with sodium and goes as NaOH, sodium hydroxide. Now, what is there in the mixture? Sodium cyanide and sodium hydroxide. That means alkaline solution of sodium cyanide, because alkali, NaOH is alkali. So NaCN contains NaOH also. So alkaline solution of sodium cyanide, which is what Lezine's extract, right? So yeah, this formed if the organic compound has nitrogen. This filtrate is what? Lezine's extract. Yeah. Next, test for nitrogen, another test. Okay. So then here 2 ml of sodium extract. I mean sodium extract in the sense which has NaOH also. So NaOH with freshly prepared FeSO4. So sodium hydroxide, instead what is it? The sodium extract, which is sodium extract in the sense the Lezine reagent. So that with ferrous sulfate leads to dirty white precipitate. Dirty green precipitate. This we might have learned in lower grades itself. So test for cation, iron reacts with hydroxide from NaOH, and it goes as FeOH twice, right? That is ferrous hydroxide, which means dirty, which gives dirty green precipitate. So once you get dirty green precipitate, that reacts with NaCN, and NaCN again in sodium extract, okay, which is present in sodium extract. NaOH also present in sodium extract, NaCN also from sodium extract. That means you have taken extract and adding FeSO4, and that leads to dirty green precipitate. And by adding FeOH again, like more with some more sodium extract, that leads to sodium ferrocyanide. Got it? Yeah. So both are sodium extract only, Lezine's reagent only. Yeah. So now once you get sodium ferrocyanide, when you add ferric chloride to that, ferric chloride FeCl3 to that, it leads to a nice blue, okay, nice blue, Prussian blue color precipitate. So that confirms it is nitrogen. Okay, yeah, that is ferrocyanide. Yeah, ferrocyanide. Yes. If it has sulfur, okay, if the same compound has sulfur with this test, when you do this test and that has sulfur also in the sense, The organic compound, like from organic compound, the carbon, nitrogen, and sulfur. So that organic unknown compound has all three elements in the sense that leads to sodium sulfocyanide, and this sodium sulfocyanide reacts with ferric chloride because the same procedure. So ferric chloride you are adding, and ferric sulfocyanide you are getting. Okay, there ferric ferrocyanide, yeah, ferric sulfocyanide, which is blood red color. Okay, so if the mixture gives Prussian blue, I missed here, Prussian blue. I'll write it. Prussian blue, which is a dark blue. I'll use blue itself. Yeah, Prussian blue. Okay, nice blue, dark blue. The Prussian blue in the sense it has nitrogen, and blood red color in the sense it has a sulfur in it, right? Okay, next. Next is deduction of sulfur. So separately, deduction of sulfur, again Lezine's test. Lezine's test, again the sodium from organic compound, the method, I mean in the ignition tube you'll take sodium, then organic compound which has sulfur. So we didn't give the whole organic compound, but we mentioned if sulfur is present in organic compound, sulfur reacts with sodium. Okay, it reacts with sodium and forms what? Na2S, sodium sulfide. Okay, so Lezine's reagent, right, which has sodium sulfide. Okay, now that sodium sulfide, I mean the Lezine's extract, right? So that we have to take it in two test tube. Okay, so if you get the sodium sulfide in one test tube, pour the half into other test tube. So you're going to do two tests with part 1 and part 2. Are you getting it? So sodium nitroprusside test. So first one, sodium nitroprusside test. With this sodium sulfide, by adding sodium nitroprusside reagent, you get violet coloration, nice violet color you get. So that violet color confirms it has sodium thionitroprusside. Got it? Sodium thionitro. Thio means sulfur. Sodium thionitroprusside. Okay, violet coloration that confirms it has sulfur. Sodium thionitroprusside because of sulfur. Thio means sulfur. Then lead acetate test. Here, then again the second part. Okay, in the second test tube, second part, we are acidifying it with acetic acid. Usually, you might have seen in barium sulfate, I mean sulfate test for sulfate. We acidify the barium, sulfate salt with HCl if you use barium chloride. If you'll acidify it with nitric acid, when you use barium nitrate. Or even in the silver nitrate test, we use nitric acid to acidify the compound, right? So acidification leads to, if any carbonate is present in it, that will goes as carbon dioxide. So that will not interrupt with the result. That is why we acidify it. So acidified acetic acid. Okay, acidified with acetic acid. Which one? Na2S. The second part. So the second part, you are adding acetic acid. Now you are adding lead acetate to it. CH3COO twice because valency of lead is 2 plus here. So lead acetate. By adding lead acetate, what happens here? The lead reacts with sulfur and goes as lead sulfide. Okay, which is black precipitate, black color precipitate. That black precipitate confirms it has sulfur. Right, so that is what the test for sulfur test. Okay, over here. Yeah, next, oxidation test. Again, this is also for sulfur only. Okay, oxidation test. If you see this reactant, you get it sodium carbonate plus sulfur. I mean sulfur from the organic compound, and we are adding potassium nitrate, which is an oxidizing agent, which provides oxygen. Okay, so 3 oxygen. So that means over here in the ignition tube, we have sodium carbonate, an unknown organic compound, and KNO3. So KNO3 is oxidizing agent. That is why we have written here. That is why we have written oxygen over here, right? So this leads to Na2SO4, sodium sulfate. But we can't identify, like we can't observe anything. So what we have to do, this sodium sulfate is added with barium chloride. So barium chloride, barium immediately reacts with sulfate and it leads to white precipitate, which is barium sulfate, right? White precipitate. So that is why arrow downwards precipitate. So this confirms, and also I told you we have to pour acid to it so that if the precipitate stays, if the precipitate is not dissolved, insoluble in the sense, then we can confirm it has sulfate. Sulfate in the sense which has sulfur in it, right? Yeah. So this is how we find the, oxidation test. Yeah. Next, detection of halogens. Over here, chlorine, bromine, iodine. Yes, we can, by doing Beilstein's test, we can detect whether the organic compound has chlorine, bromine, or iodine in it. What is it? A clean copper wire. Okay, a clean copper wire you have to take. The copper wire you have to heat the copper wire. Okay, heat the copper wire nicely in the non-luminous flame, which means blue flame. Okay, blue flame, non-luminous flame. Luminous in the sense there are yellowish orange flame. Non-luminous, on top a blue color flame you can see. So that that's one where the temperature will be high over there. Yeah. So the blue flame. So the copper wire, by heating the copper wire in the Bunsen burner, okay, Bunsen burner, what happens? The wire turns into red hot, like when you heat it, when you keep the wire in the flame after a while, the flame in the flame you can see blue or green color flame. The flame turns into blue or green. So that confirms it is copper. Actually, the copper's flame test to blue or greenish flame. Yeah. So till you have to heat it till the color goes. Okay. Then touch the wire, touch the copper wire. The hot end of the wire into the given organic compound. So then again keep it on the flame in the non-luminous flame. So what happens now? After a while, if you get the blue or green flame again, that indicates it has a halogen. Okay, that indicates it has halogen in it. Okay, so what is it? That means copper wire reacts with halogen and becomes copper halide. What we got, that bluish or green flame at the end, which is copper halide. Okay, so urea, thiourea, important one. Urea and thiourea also respond to this test. Okay, so it is not the confirmatory test. Got it? A halogen will leads to a copper halide and you get this flame. But urea and thiourea also give the same result. So we can't confirm by seeing the flame. You can't confirm it has a halogen in it. Okay, so then what we have to do? Lezein's test to confirm it has halogen. So sodium extract again. The X in the sense a halogen, any halogen. It can be chlorine, bromine, or iodine from the organic. From the sample or from the sodium extract. Okay, yeah. So here this is sodium extract, but over here this is what? Organic compound. Okay, unknown organic compound. We don't know what it is. So unknown organic compound. So in that the X alone, the halogen alone reacts with sodium. Again, repeatedly, like they will not give you repeatedly, but Lezein's test in the sense in ignition tube, sodium organic compound which has halogen, burn it, boil it, and then final solution is sodium extract. So that's how you get this sodium extract. It can be NaCl, NaBr, NaI, anything. So when that reacts with silver nitrate, again silver nitrate is for halogen test. So with the silver nitrate, you get silver chloride, silver bromide, or silver iodide. So that gives a precipitate. We know silver chloride is a white, which gives white precipitate. Silver bromide, which gives cream precipitate or yellowish white precipitate, and silver iodide gives yellow precipitate, right? But another important information here, the AgCl gives white precipitate, but it is soluble in ammonium hydroxide. Even with solubility with the ammonium hydroxide also confirms it is that element, that halogen, yeah. So soluble in ammonium hydroxide. If it is AgBr, I told you cream precipitate or yellowish white precipitate. In that case, when you dissolve in NH4OH, ammonium hydroxide, sparingly soluble in ammonium hydroxide. And AgI, which gives yellow precipitate, it is insoluble in ammonium hydroxide. Got it? Yeah. So this method is not helpful in nitrogen or sulfur present along with halogen. If the organic compound has halogen and also has nitrogen and sulfur in the sense, we cannot do this method. Why? Because the sodium reacts with sulfur and forms sodium sulfide, and sodium reacts with nitrogen, forms sodium cyanide. So when you add AgNO3 with this, what happens? You get Ag2S, silver sulfur. Instead of getting silver halide, you get silver sulfide. Instead of getting silver halide, you get silver cyanide. So silver sulfide you get black precipitate too. So what happens? It covers the white precipitate or yellow precipitate which you get in the test tube. So we cannot see clearly. And if AgCN forms, AgCN as well as AgCl forms in a sense, you cannot differentiate the color because both are white precipitate. So you don't know whether it is AgCl or AgCN, right? So what we have to do? We have to boil the extract with concentrated HNO3 before doing the test. So boil the extract, okay? If it has Na2S or if it has cyanide, NaCN, what happens? The cyanide goes as HCN and goes as a gas. So it liberates as a gas. So it escapes. So HNO3 reacts with Na2S. What happens here? Concentrated HNO3. Okay, keep that in mind. It liberates as H2S. So the gases will go off. What will be there in the solution is, so halogen, only halogen will be there. So then it is ready to test halogen. Got it? Yeah. Next. Okay. Next. Chloroform. Chloroform layer test. So what is that? Then once you add nitric acid, you got you have removed HCN, you have removed H2S, you have only halogen in it. Now what you have to do? Chloroform layer test for bromine and iodine. This is for only bromine and iodine. Okay. So now the sodium extract acidified with HNO3. So 1 ml of chloroform and excess of chlorine water you have to add to it. Then shake well. So what happens here? Bromine, chloroform layer becomes brown. If it is bromine, chloroform layer becomes chloroform layer on top, it turns into brown. Why? Displacement reaction, right? So chlorine displaces the bromine from the NaBr so that you get bromine. That bromine gives that brown color, right? If it is iodine, the chloroform layer turns into violet color because the color of iodine is it's a violet color, like blue, black kind of. So you will get violet color layer. So again, it is a displacement reaction. Chlorine displaces the iodine so that the iodine on the chloroform layer gives violet color. Again, this test is not interfered by nitrogen and sulfur, so that it gives only bromine test and iodine test. Yeah. So finally, last one, detection of phosphorus. So here, organic compound with potassium nitrate and sodium carbonate. What is it? So potassium nitrate is what we have seen before, oxidizing agent, right? When oxidizing agent and sodium carbonate reacts with the organic compound, you will get a fused mass. So instead of this oxidizing fusion mixture, you can use sodium peroxide too. That also gives the same thing. So fused mass. With this mass, you by adding ammonium molybdate, NH4 twice MOO4. Okay, MO molybdenum, ammonium molybdate. Okay, by adding this, the mixture leads to yellow precipitate. Yellow precipitate means which shows ammonium phosphomolybdate. That means presence of phosphorus. Got it? Ammonium phosphomolybdate. Ammonium molybdate turns into ammonium phosphomolybdate. So that means it confirms it has phosphorus in it. Right? Yes. So this is what detection of elements in organic compounds. Hope you understood the concept. Thanks for watching. And if you want any other topic if you want me to teach anything, let me know. The next topic is yours. Yeah. Thank you. Bye bye.